myself Rajeswari, Assistant Professor, Department of BCA. Today we are going to discuss about data link layer. So what is meant by data link layer? It is main responsibility of the data link layer is to transfer the datagram across an individual link. The data link layer protocol defines the format of the packet exchanged across the nodes as well as the actions such as error detection, retransmission, flow control and random access. The next one is services of data link layer. Data link layer services, first one is error correction. Error correction codes are used to detect and correct the errors when data is transmitted from the sender to the receiver. Error correction can be handled in two ways. First one is a backward error correction. Once the error is discovered, the receiver requests the sender to retransmit the entire data unit. The next one is forward error correction. In this case, the receiver uses the error correcting code which automatically correct the errors. A single additional bit can detect the error but cannot correct it. The next one is humming code. It is the system of receiving the data transmission where enough error checking information included with the data so that the receiving system can automatically correct single bit mistakes with enquiring from the sender. The error detecting and error correcting properties of a code depend on its humming distance. The detect D errors, you need a distance D plus 1 code because with such a code there is no way that D single bit errors can change a valid code word into another valid code word. When the receiver sees an invalid code word, it can tell that the transmission error has occurred. Similarly, to correct D error, you need a distance 2D plus 1 code because that the way legal code words are so far apart that even with D changes, the original code word is still closer than any other code word. So it can be uniquely determined. The next one is error detection. When data is transmitted from one device to another device, the system does not guarantee whether the data received by the device. It's identical to the data transmitted by another device. An error is a situation when the message received at the receiver end is not identical to the message transmitted. The next one is a single bit error. The only one bit of a given data unit is changed from 1 to 0 or from 0 to 1. In the above figure, the message which is sent is corrected here as single bit. For example, 0 bit is changed into 1. Single bit error does not appear more likely in serial data transmission. For example, sender sends the data at 10 Mbps. This means that the bits lost only for once, and for a single bit error to occur, a noise must be more than once. Single bit error mainly occur in parallel data transmission. For example, if 8 wires are used to send the 8 bits of a byte, if one of the wires is noisy, then single bit is corrected per byte. The next one is burst error. The 2 or more bits are changed from 0 to 1 or from 1 to 0 is known as burst error. The burst error is determined from the first corrected bit to the last corrected bit. The next one is an elementary data link protocol. Data link protocol is concerned the packet passed across the interface to it from the network layer is pure data. When the data link layer accepts a packet, it encapsulates the packet into the frame. Frame consists of an embedded packet, some controlled information and a checksum. The frame is then transmitted to the data link layer on the other machine. The step 1 is the procedure called wait for event. The procedure only returns when something has happened. Step 2, when a frame arrives at the receiver, hardware computes the checksum. If the checksum isn't correct, there was a transmission error. The DR informed event is equal to checksum minus error. Step 3, frame arrived at undamaged data layer is also informed event is equal to frame minus arrival. Step 4, data structure are defined boolean, sequence, packet, frame kind and frame. Boolean can take one on the values true or false. Sequence, it is a small integer used to number the frames. The sequence number run from 0 up to and including maximum sequence. Packet. The packet is the unit of information exchanged between the network layer and the data link layer on the same machine. The next one is frame is composed of 4 fields. First one is a kind, second one sequence, third one is acknowledgement, fourth one is an information. An unrestricted simplex protocol. In this method, data are transmitted in one direction only. Both the transmitting and receiving network layers are always ready. Processing time can be ignored. Infinity buffer space is available. The communication channel between the data link layer never damages or lost frames. The next one is a simplex stop and wait protocol. The ability of the receiving network layer to process incoming data infinitely quickly. The communication channel is still assumed to error-free. The main problem we have to deal with here is how to prevent the sender from floating the receiver with the data faster than the latter is able to process them. The sender must never transmit a new frame until the older one has been fetched by frame. Physical layer, the new one override the old one. Receiver provide feedback to the sender. The next one is a simplex protocol for a noisy channel. A sender could send a frame, but the receiver would only send an acknowledgement frame if the data were correctly received. If a damaged frame arrives at the receiver, it would be discarded. This process would be repeated until the frame finally arrived intact. The next one is a sliding window protocol. Transmitting data in both directions, one way of achieving full duplex data transmission is to have separate communication channel and use each one of simplex data traffic. The data frames from A to B are intermixed. The acknowledgement frames from A to B header incoming frame. The receiver can tell whether the frame is data or acknowledgement. The technique of temporarily delaying outgoing acknowledgement so that they can be into the next outgoing data frame is known as picky packing. The next 3 protocol are a bidirectional protocol that belongs to a class called sliding window protocol. Sender maintains a set of sequence corresponding to the frames. It is permitted to send these frames are said to be fall within the sending window receiver. Also maintain receiving windows. The next one, the sender must keep all these frames in its memory for possible retransmission. The maximum window size in N, the sender needs N buffer to hold the acknowledgement frame. Receiver when frame whose sequence number is equal to the lower edge of the window is received. It is passed to the network layer and it's generated and the window OS rotated by the 1. The receiver window always remains at its initial size. It uses the concept of sliding window and so is also called sliding window protocol. The frames are sequentially numbered and a finite number of frames are sent. If the acknowledgement for a frame is not received within the time period, all frames starting from that frame are retransmitted. Selective repeat acknowledgement queries. This protocol also provides for sending multiple frames before receiving the acknowledgement for the first frame. However, here only the errors or lost frames are retransmitted while the good frames are received and buffered. The next one is the medium access control sub-layer. Broadcast channels are sometimes referred to as multi-access channels or random access channels. The protocol used to determine who hosts next on a multi-access channel belong to a supplier of a data link layer called the MAC, which means medium access control, which use a multi-access channel as the basis of communication. Multi-access protocol. The data link layer is responsible of transmission of data between 2 nodes. Its main functions are data link control, multiple access control. Data link control. The data link control is responsible for reliable transmission of message over transmission channel by using techniques like framing, error control and flow control. For data link layer control, refer to stop and wait. Data link model. Data link control protocol regulate the flow of data. Frames is supplemented with control bits of allow reliable data delivery. The next one is a multiple access control. If there is a dedicated link between the sender and the receiver, then data link control layer is sufficient. However, if there is no dedicated link present, then multiple stations can access the channel simultaneously. Hence, the multiple access protocol are required to decrease collision and avoid crosstalk. For example, in a classroom full of students, when a teacher asks a question and all the students start answering simultaneously, then the lot of choices is created. So then the job of teacher to manage the students and make them answer one at a time. The next one is an Ethernet. The LAN marked has seen served technologies, but the most dominated today is Ethernet. Three generations of Ethernet are available. Traditional Ethernet, the next one is in fast Ethernet, the fourth one is in gigabit Ethernet. Traditional Ethernet, it is designed to operate at 10 Mbps. Access to the network by a device is through a content method. The media are shared all stations. Wired Ethernet network. The Ethernet technology mainly works with the fiber optics cables that connect device within a distance of 10 km. The Ethernet support 10 Mbps. The computer network interface card is installed in each computer and is assigned to a unique address. An Ethernet cable runs from each NIC to the central switch or hub. The switch and hub act as a relay through. They have significant difference in the manner which they handle network traffic, receiving and directing packets of data across the LAN. Thus, Ethernet networking creates a communication system that allows sharing of data and resources including printers, fax machines and scanners. The next one is on wireless Ethernet. Ethernet networks can also be wireless. Rather than using Ethernet cable to connect the computers, wireless NICs use radio waves for two-way communication with a wireless switch or hub. It consists of Ethernet ports, wireless switches and hubs. The next one is on wireless network technology can be more flexible to use but also require extra care in configuring security. Types of Ethernet network. First one is on fast Ethernet. Fast Ethernet is a type of network that can transfer data at a rate of 100 Mbps using a twisted pair cable or a fiber optic cable. The older 10 Mbps Ethernet is still used, but such networks do not provide necessary bandwidth for some network-based video applications. Fast Ethernet is based on the proven CD Media Access Control Protocol. And uses existing 10-way stick cabling. Data can move from 10 Mbps to 100 Mbps without any protocol translation or changes to the application and networking software. The next one is gigabit Ethernet. It is a type of Ethernet network cable of transmitting data at a rate of 1000 Mbps based on a twisted pair or fiber optic cable. And it is very popular. The type of twisted pair cable that supports gigabit Ethernet is Cat5e cable, where all the four pairs of twisted wires of the cable are used to achieve high data transfer rate. The 10 gigabit Ethernet is the latest generation Ethernet capable of transferring data at a rate of 10 Gbps using twisted pair fiber optic cable. The third one is switch Ethernet. Multiple network devices in a LAN require network equipment such as a network switch or hub. When using a network switch, a regular network cable is used instead of crossover cable. The crossover cable consists of a transmission pair at one end and a receiving pair at the other end. The main function of a network switch is to forward data from one device to another device on the same network. Thus, the network switch performs this task efficiently as the data is transferred from one device to another without affecting other devices on the same network. The network switch normally support different data transfer rate. The most common data transfer rate include 10 Mbps to 100 Mbps for fast Ethernet and 1000 Mbps to 10,000 gigabytes for the latest Ethernet. Switch Ethernet uses star topology, which is organized around the switch. The switch in a network uses a filtering and switching mechanism similar to the one used by the gateways, in which these technologies have been in use for a long time. The next topic is Bluetooth. Bluetooth is a way to exchange data with other devices wireless. Android provides Bluetooth API to perform several tasks such as scan Bluetooth devices, connect and transfer data from the other devices, manage multiple connections, etc. Bluetooth application, the most network protocol just provide channels between communicating entities and let application designers figure out what they want to use them. For example, 802.11 does not specify whether users should use their notebook, computers for reading email, surfing the web, or something else. In contrast, the Bluetooth VI.1 specification names 13 specific applications to be supported and provide different protocol stacks for each one. Bluetooth layers. Bluetooth uses several layers that do not exactly match those of the Internet model. TDMA, time division multiple access. It is a half duplex communication in which the slave and the receiving send and receive the data but do not at the same time. Example, walkie-talkies using different carrier frequencies. Single slave communication. The Piconet has only one slave. The TDMA operation is very simple. The time is divided into slots. The master uses even slot. The slave uses odd numbered slots. TD and TDMA always uses the master and the slave to communication in half duplex mode. The next one is a multiple slave communication. More than one slave in the Piconet. Again, the master uses the even numbered slot, but the slave sends the next odd number slot is the packet in the previous slot was addressed to it. Okay, thank you.